Hello everyone. This is a video lecture for College Algebra, Math 1314, Section 9.2. We're doing inconsistent, dependent, and I guess regular matrices. So, first off, they're just going to say solve. We're going to solve for this matrix just like we did other times. And I'm going to pull up Desmos matrix calculator. So we go to Math Tools, Matrix Calculator, and I'm going to put this thing in. And just like last time, I'm going to need to have this a little bit smaller for me to be able to write it back and forth kind of quickly. So, if you don't mind. I want to show you the basis, the purpose of this section first, but I think it'll be better to just show you what Desmos matrix calculator will give you, and then we have to like interpret it, I guess, and that's part of the section here. It's interpretation. That's good enough. All right, so let me show you what we're doing again. So new matrix, and then I need to make this a 3 by 4 to be able to fit all these numbers, and then I start typing them. So we got 9, 29, 6, and 13. And this should just look like any old problem that we've already seen. So, cool. Hit enter. And then again, RREF, or you can click it. Either way, we get an answer. But what you should see now is that this answer is different than what we've seen in other times. So, how do I interpret this answer? What should I be putting in my math homework program? You know, all that kind of stuff. So, let me write that down. We got a negative 38 and a 12. Okay. So negative 38. And then we have a plain old 12. And then a 0, 0, 0, 1. Okay. So if I were to rewrite this as equations, because we can go back and forth between them, this here would be x minus 38z is equal to 0. This one here would be a y plus 12z equals 0. But the bottom one is interesting. 0x, 0y, 0z is equal to 1. If you look right here, basically you have 0 is equal to 1. And that's false. False. How do you put that then? What's the answer then? This is called this is called inconsistent, or you could say no solution. They're all very correct. All these are good. This is the way you should put it. So put that in as an answer, click that button, whatever you need to do, and you're done. There's really nothing else to do. What you should in the future be seeing is right here, if you have 0, 0, 0, and then a 1 right there, that's going to automatically flag that as a no solution kind of answer, okay? Like that's it, and no other math. We're done. So let's keep going and try it again. So it says solve, and we're going to solve. I'm just going to write this again really tiny up here, even tinier than last time because it was still hard for me to see. Okay. Cool. And so just like last time, I'm going to do the same thing. So just showing you again, new matrix. It's a 3 by 4. And now we're going to, there we go. There we go. And now I'm going to go ahead and type this thing in. Okay. Just like last time. RREF. That's how we're... Oh, uh-oh. And so, in previous videos, I said, hey, if you got some kind of weird decimals or fractions, you could have them as an answer, but it's rare. And I'm going to tell you that this is actually okay now. Expect it more often right now in this section. So these decimals obviously can translate easily into fractions, and thankfully Desmos can do that for me. So what I'm going to do is I'm going to write these down so that I can get these down. So -4/3 and 28/3. Yes, it's a little painful having to go back and forth here. I'm sorry. -4/3 again, and then a -8/3. And then 0, 0, 0, and 0. That is actually one of the more important components here, all zeros. And so just like last time, I'm going to go this way with it, I guess. So this is my x, my y, my z equals a number. And I'm going to rewrite it. So then I got x minus 4/3 z is equal to 28/3. For this one, I've got y minus 4/3 z is equal to -8/3. But the bottom here is different now. 0x plus 0y plus 0z is equal to 0. If you look at this, we got 0 is equal to 0. True. If I could spell true, that is. True. Cool. So we got a true statement in the bottom. Like, this is okay. This right here, that's okay. But I still don't have a perfect answer. So what are you going to put for your answer in your math homework program? Well, they are insisting that you solve for x and y and z. And so what we're going to do is do the best we can. I'm going to start solving for x right here. I'm going to take this, I'm going to add it to the other side. So I got x is now equal to that 28/3 plus 4/3 z. And there you go. I solve for x. Okay. My y. Same thing, I'm going to add y. Same thing, I'm going to add this to the other side. So I get a -8/3 plus a 4/3 z. Again, I did technically solve for y. And then z. What should z equal? And you're thinking 0. That's the most common thing I've heard. No. Z is not equal to 0. Z is equal to z. Just like that. That's weird. And so your math homework program, depending on the question that is, it might have the 2 boxes and then a z here, and then you gotta type those things in. I'm not gonna do it again, but you see the point. It already has a predefined z. It could. There's other ways, but I'm just gonna say that's the most common thing to do. And so there's a name for this one. It's called deep. That's another way to use solutions. Infinite solutions. Because your z could be anything. Is your z 0? Well, it could be. Is your z 1? Well, it could be. Could z be 100? Yeah. And now on to question 3. So, yet again, solve. And you can see that this size is a little different this time. So we have a 2 by 4. A 2 by 4, actually. If you were to kind of put that into a matrix like that. And of course, there's going to be a 0 there. Let me go ahead and translate this over into a matrix. And I'll do it kind of tiny up here yet again because I'm going to be using Desmos. So that's going to be a 0x, a 1y, -7z, and then a 3. At least it's a little bit more compatible because it's so much shorter. Okay, so yet again, new matrix. This is going to be a 2 by 4 though. So that's what I'm going to put in. RREF of A, and there we go. That does not mean that it's a good answer. Well, okay, it's good. It's true, but it doesn't mean that it's wrong, or I don't know. We're gonna try it. Let's just see what it means. Just like as if we were to get any kind of answer, we should probably write it down and assume that it probably will work somehow. And so we got a 18 and a -7. It just looks weird. Let's just say that. Okay, so there's my answer so far. Well, remember that this was x, y, z equals a number. And so I need to rewrite these as two equations. So then I got x plus 18z is equal to 3. And at the bottom I got a y minus 7z is equal to 3. And they're wanting to solve, I guess. There's not a lot going on here. Can I at least solve for x? Yes. I'm going to move this over to the other side as a negative. So then I got 3 minus 18z. For my y's, I'm going to move this over. Now it's going to be a positive. 3 plus 7z. And again, what does z equal to? Z equals z. But most of the time they'll already provide that. And so you would type this into your math homework program. You'll most likely have the two different ones there. This is a dependent, just like the last one. And there's infinite solutions, etc., etc. So just like the last one. All right. Now, for the last question, and this is going to be a pretty big one. So I have a lot of one-way streets, and we're supposed to find out the traffic that's going on here in W, X, Y, and Z, given all the amounts of traffic on the outside. So I already know all of these, but I don't know what's going on in the inside here. And so what we need to do is set up some equations. In this way, this equation that we're going to be using a lot here is going to be in equals out. For each intersection, we want in equals out. So if you come into this intersection, you can go out of the intersection. Or you go into the intersection, you go out of the intersection. Or you come in, you go out. Or you come in, you go out. Every time you're going to be going in, you're going to have a going out. And each intersection is going to be its own thing. So I'm going to actually like circle this as the intersection. And notice that I'm trying to include all those numbers there. So let me start listing out what these would be. So going in, again, we got in is equal to out. Going in, I'll just do that. We have a 160 and a 180. Going out, I have a W and a Z. Notice that I'm not trying to talk about these guys over here. It's just whatever is really close to that intersection. I'm trying to use different colors so you can see what's going on here. Well, the next one I have is in W and an X, but going out would be the 360 and the 180. Use more colors. Let's do this section right here, intersection right there. So going in, I have a Y and a 180. Going out, I have an X and a 30. And for the last one here, so going into that intersection is the 120 and a Z. Going out is going to be the Y and a 70. Okay. So with these equations down at the bottom now, I need to rewrite them into a way to get them into a big matrix. And so I'm going to start listing this out as we got W, X, Y, Z equals a number. And so the very first one I already got is a W plus Z, so 1, 0, 0, 1. And then if you add these together, that would make a 340. Again, it's always best to check on the calculator. Yep, 340. This next one, I got a W and an X, no Y's, no Z's, and that's going to be a 500 something. 540. This guy's a little different, though. I'm actually going to move the Y to this side here and move the 30 over there so that you get a so no W's, one positive X. Your Y on this side is going to be a negative now. And then no Z's to speak of. I got 180 minus 30 is 150. And the same thing here. I'm going to move the z over and move the 70 over. And so then we have a 0 w's, 0 x's, 1 y, negative 1 z when it moves over. And then when you're minusing your 70 over here, I think it's just going to be a 50. But again, I'm going to verify with the calculator. Yep, 50. Okay, now I did not write those intermediate steps down. You can if you want. My point, though, is that it's not very difficult. Just go ahead and type it all in here. Now, this is a 4x5 matrix, and then we're going to RREF as we always do, and we're going to get an answer. Obviously, this one's huge, so I'm going to do the very best I can to make this thing work within the view screen here. And so, new matrix, we're going to do a 4x5. Yes, you can still see that. Okay, so lots of typing. But it's so much better than doing it by hand. Just always remember that whenever you're typing all these numbers. I haven't even shown you by hand. You don't want to see that. RREF of A, and we got some answers down here. Notice that they're not perfect, and so I'm going to have to write these out a little bit more carefully. I think the top one hasn't even changed, and this bottom has moved up to the third row. You see that? So the only one that's actually changed is going to be this middle one right there, and it's going to be a 200. Okay, so let me write out my answer then. And I know it's weird that some things have not changed. It just shows that our original was actually really simplified already. And then the bottom is all zeros. We've seen this before. If it's all zeros, then it's dependent automatically. So in order to get the answers, it's actually kind of fast if you've been picking up on some of the patterns. This is the Z column, and if I technically just move them over to the other side, that means change their sign, then you automatically get your answers. So W is equal to 340 minus Z. X is equal to 200 plus Z. Y is equal to 50 plus Z. And again, if they ask, what is Z equal to? It's equal to Z. Okay, awesome. So there's another component to this problem. After this, they say, hey, I'm glad that you got some answers here, and you would actually have to type these in. These are real answers for your math homework program. But they're going to say, well, hold on. Z is equal to 40. Now find out what W, X, and Y are from that. So I have 340 minus 40 would be 300. I have 200 plus the 40 is 240. And then Y is 50 plus 40 is 90. And what is Z equal to? In case they ask, it's 40. They told me that. And you can't get this unless they tell you. This was given to you. Okay? Now, on your homework, you actually have about 3 problems like this. I combined them all into a single one big problem. So I did a whole bunch of stuff here that each one of those problems you do individually. You do like pieces of it. I did it all at once. Okay, awesome. So that's the last one I actually have for you. So thank you very much and have a great day.